Okay, Assalamualaikum. Uh, Let me explain to you how to do calculation for bend. Okay, so now see, this is the data for elbow. Okay, elbow and meter bend, they are the same. So you can do exactly the same way. Main thing is in elbow we measured the head loss H1 H2. So this one H1 H2 is not only the head loss uh, in the elbow or in the bend, but also it is included like we have straight pipe section. Okay, so a straight pipe section also there. So if you I can open the manual, you can see, yeah, this one. So we have measured the head loss like at this point and this point. So actually we need head loss up to here only, to here. Okay. So but we have measured this one for some technical purpose, technical reason. So this one and this point and this point, we have H1 minus H2. So what we need to subtract the head loss which will happen in this section. So head loss in a pipe, pressure loss in a pipe. You did the last experiment, and we will follow the same procedure. So first of all, we need to subtract this term. Okay. So how we'll know? We will need to find for a given Q. We can find the velocity. We can find the round number. We can find the friction factor, and then we'll find the pressure drop. Okay. So let me go back to this data. We have flow rate. So what we can do, we can find the velocity. Okay, velocity is flow rate divided by area, right? Area, and this make dollar. So this is the velocity. Okay, then I can find the Reynolds number. Velocity times density times diameter, and this should be fixed. Okay, diameter divided by the viscosity. Viscosity is uh, at around 20 degrees centigrade is 0.889, something like this. 0.00089. Okay, or we can use as 0.001. So this is 1 cp. Okay, and then we have uh, this is smooth pipe. So we are trying to find the head loss which will occur in the straight section of pipe. So this is friction factor, and then what we have 0.79 times Re power minus 0.25. Okay, so this is a friction factor in a pipe. Okay, now what we know, friction factor is related to F is delta P over 2 rho V square D over L, right? So now from friction factor, what we will have, we need delta P. So delta P will be F time 2 rho V square L over D equal delta P. And if you want delta H, we need to divide by rho G. So rho G, so rho will cancel. This is the head loss in pi, which is here. So 2, this will be 2, right? So 2L V square 2LF 2 LFV square over GD. Okay, so now we can find head loss right away in pipe. Head loss in a pipe. So that is 2 times F times L. L is this. Okay, function F4 L divided by diameter, which is this. Okay, that's it. Sorry, we have in GD, so G also there, times 9.8. So this is the head loss in pi. Now head loss in bend, how we can find? The head loss, you can say total head loss, which was including pipe plus bend. So this was uh, H1 minus H2. Yes, H1 minus H2. So in meter, it will be H1 minus H2 divided by 1000. Okay. So okay, here I think there is something. Yeah, V square is missing. Okay, times velocity square. Okay, head loss in a pipe. Once we find the friction factor F, 2 FLV square over GD. So this is the head loss in pipe. So what we do, we will subtract total head loss minus head loss in pipe. So that is basically in bend. So this is delta H in the bend. So what we need to find K, right? This is K. Head loss in bend divided by V square over 2G. So that is clear here. So head loss divided by V square over 2G. So K 0.91. This is elbow, right? Short elbow, extended elbow. So now you can see K values are yani close, 0.91, 0.98. Okay, 1, 0. This is a little bit less. So average of this will be 0.9. Okay, and then we expect that K value should be constant, should not change. So whatever it is coming because of experimental error. So standard deviation we want to calculate standard deviation. So how much the deviation is? So what we can say, our standard our K value is 0.9, 0.90, and with the deviation of 0.1. So 0.1 is deviation, it means it's not deviating much. So we can say that it is constant and deviating around 0.9. What you can do, you can plot the average value together. Okay, so this is the average value and K average, K average. So when you plot, there is plot K versus the non number, right? So K versus, this is the K. Yeah, so see the trend. Oh my god, this is increase decrease. um, edit Renault number. What is Renault number? Is this one? Okay. Now you see this one increase decrease. We can make the axis a little bit bigger. So major minor minimum is maybe minimum 0.5, maximum 2. Okay. So now we can see it's not deviating much. Okay. Or even we can do it in better way. So minimum say 0, 0.5, and maybe 2.5. So you can see these values. Okay. Or this is coming down, so better we keep it 0. So what we can do, we can plot also the average one together. Okay. And this average constant average and Renault number. Where is Renault number again? Something wrong. And okay, average. Renault number. Yes. So you can see these are the constant values. So you can say that my value is deviating around this value 0.9, and you will compare this value k value with the literature. You will find the loss coefficient of standard elbow. Okay. So this is the calculation for elbow. Okay. And then you have contraction and enlargement. Okay. So I will stop at this point. Hope it